G'day again, last video on simultaneous equations, and what we're doing is we're going to be solving simultaneous equations this time using a much faster method, and this method is called the method by elimination. And what we're doing is we're eliminating variables in this method. Okay, so when should we use this method? You'll use this method most of the time, to be honest. But the way to pick it is, if you remember from my last video, that if you got negative 2x plus 3y equals 9 and 16x minus 4y equals 3 or something like that, you don't know what y equals or x equals in this case. You could rearrange them to find out what y is equal to blah blah blah, but it's not worth your while. When you have this sort of situation, it's a bit more complicated. Elimination is the way you want to go. And that's basically it. What we're looking for in elimination is to have the two coefficients of one of the variables the same. So if we had 2x plus y is equal to 9 and 2x minus 5 for y equals 3, can you see how that the numbers in front of x here are the same? Oh, that's supposed to be green. We've got a 2 in front of that x and a 2 in front of that, and that's what we're looking for. We're trying to make this sort of thing happen. Okay, so that's what we're looking for. Keep that in the back of your mind as we do this. We're going to try to eliminate them, but we need those to be equal. It could also be something that looks like this: negative 3y plus 4x equals 2, and 3y minus 7x equals 9, or negative 9, or something like that. The numbers here, can you see how the coefficients of y are, inverted commas, the same? There's a 3 and a 3 there. So that's what we're looking for in an elimination method, to be able to eliminate them. Because what we're going to be doing is adding the entire equation to this entire equation, and that'll eliminate the y's. In this case, we're going to be subtracting this whole equation from this equation to eliminate them. This is best done in an example. So let's get straight into an example. Let's go. So an example, let's go negative 2x plus y is equal to 10, and 2x plus 3y is equal to 14. So straight away you can see, if you look at the x variable here, it has the same number in front of it. We've got negative 2 and positive 2 here. And you can also see that you don't know what y equals or x equals, so the substitution method here is difficult. So elimination is this. What we do in the elimination method, and I'll just go to a red pen, is we want to eliminate one of the variables. And how we can do this is by either adding or subtracting one equation from the other. Now, can you see, if I've got negative 2x here, positive 2x there, if I add those two together, so just add those two together, can you see that I'll get 0? In fact, that will eliminate. And if you can do that, if you can make that happen, force it to happen, whatever, then you can do that with every other term in these equations, and what you can do is just add them all up together. So, what do you get if you add them all up together? What's negative 2x plus 2x? You get 0x. I wrote it down, but you won't do that. What happens? You go y plus 3y, you get 4y, and 10 plus 14 is 24. So what you've done is just added the two equations together, which makes sense if you probably get it proved in class, but it makes sense. If this is equal to this, and this is equal to this, then if you add those two things together, then that'll be equal to adding these two together. So it just makes sense. So we're adding all the parts together, and that 0x just disappears. You can see that it disappears, and that's why we've done it, to make it disappear. Added a plus in there. So solve this. We've got 4y equals 24, therefore y equals 24 divided by 4, which is 6. Can you see how quickly a solution comes out if you do this? The tricky bit then is, though, how do we find x? You remember from the last method we had that we've got x equals, but we don't have that here. So what we need to do is just substitute the y equals 6 back into one of these equations. Now it's up to you, it doesn't matter which one you choose, you'll still get the right answer. I would probably tend to pick the one that has more positive numbers in it. So in this case I'm just going to choose that one. But it really doesn't matter. As long as your algebra is good, you're fine. Okay, so let's substitute y is equal to 6 back into this bottom equation. So we've got 2x plus 3, but we know the value of y. Y is equal to 6. So 3 times 6 is equal to 14. Therefore, 2x is equal to, now this is 18, bring 18 onto this side, we get 14 minus 18, that's negative 4. Therefore, x is equal to negative 4 divided by 2, which is negative 2. And so there are your two solutions. X is equal to negative 2, y is equal to 6. That is your case. Now I haven't said this in any of the other videos, but you can always check your answers with equations or simultaneous equations. If you substitute these values back into either of these two equations here, these should be true. Okay. Now we just used this equation, so it's no point checking back in there because we've just used it. Let's do it up here. Negative 2x. So negative 2 times negative 2 is 4. 4 plus the value of y. 4 plus the value of y. Y is equal to 6 is equal to 10. It works. So that's the correct solution. So that's the good thing about simultaneous equations. You can always check your answers, or any equation. You can always check your answers by substituting the answer back in and making sure it's true. Let's have us a look at another example. Let's go 2x minus 5y, and it should be equal to something, otherwise it's a bit trivial, plus y is equal to 7. Okay, so let's have a look at these two. Let's go back to my red pen. I'm drawing all over it. Let's have a look at this. Which variables have something similar in front of them? And let's have a look at the y's. Well, we've got a 5y and a 1y. They don't have the same coefficients. Can you see if you added them or subtracted them, you don't get 0, lots of y there, so it doesn't work. Okay, but the x's do. What we can do, we've got positive 2x here, positive 2x here. What we can do is subtract them. Okay, so 2x minus 2x. And so we can actually subtract all the other parts as well. Subtract that part and subtract that part. Let's see what we get. Therefore, 2x minus 2x is 0x. That's just going to disappear. Okay, and that's the reason we've done it. We've eliminated the x variable. Here, be careful here. We've got negative 5y minus y, which is minus 6y, is equal to negative 11 minus 7. That's negative 18. Solve it. Therefore, y is equal to negative 18 divided by negative 6, which is equal to positive 3. So there's your y value. Y is equal to 3. And now how do we find x? We substitute it back into one of these original equations. I am looking at this one here because it's got 2x plus y. They're all positives. Let's deal with positive numbers. Much easier, much quicker. Okay, so therefore, we've got 2x plus y. What was y equal to? Y is equal to 3 equals 7. Therefore, 2x is equal to 7 minus 3, which is 4. Therefore, x equals 2. And there's your solution. Again, let's check it in this equation that we didn't use up here. 2 times x is 4, minus 5y minus 15, 5 times 3, is equal to negative 11. It works. Yes. So that means I've got the correct solution. Okay. Let's do one more example because I know what you're asking. You're saying, what if the numbers in front of the x and the y are not the same? Good question. Okay, so let's do last one. Let's do negative 2x plus 3y is equal to 3, and 5x minus 6y is equal to negative 3. Okay, let's roll this one. So now we've got the situation you just bleated about. The numbers in front of the x are not the same. The numbers in front of the y are not the same. What can we do? Well, I'll just number these equations. Okay, so we've got equation 1 and equation 2. Can we change one of the equations so that they do have the same number in front of them? Okay, what can we do? Well, look at this. Maybe we can just times equation 1 by 2. If we multiplied everything by 2 in this equation, which is fine, as long as you do the same to both sides of an equation, you haven't changed anything, then that's fine. And that will become 6y, and then we've got a negative 6y, that's okay. So what we're going to do is we're going to say, what's 1 times by 2? Let's do it. Right, what's negative 2x times by 2? That's negative 4x. Okay, what's 3y times 2? That's positive 6y. What's 3 times 2? That's 6. And now we have this new equation here. And look, lo and behold, it matches. We can now do something. Now, do we want to add them or do we want to subtract them? Well, we've got negative 6y. We want to add them. What's negative 6y plus 6y? That's 0. If you subtracted them, you'd get negative 6y minus 6y. That's negative 12y. So that doesn't work. So we must add them together to get 0. Because we added that one, we need to add all the others as well. Add that one and add that one. So let's do this. 5x plus negative 4x, so that's 5x minus 4x. That's equal to x. That's going to be equal to 0. So equals negative 3 plus 6 is 3. Oh, there's the answer. Can you see how quick this method can be? Especially if you can do these things in your head. Just doubling it and then they all cancel out. Okay, so x is equal to 3. How do we find y? We substitute back into one of these equations. Which one? Let's do the first one. Okay, it could be the second one. Doesn't really matter. Both of them are muchness. One doesn't look better than the other here. Okay, so negative 2x. That's negative 2 times 3 plus 3y is equal to 3. Therefore, 3y is equal to, so this is negative 6, move negative 6 to the other side, is positive 6. 3 plus 6 is 9. Therefore, y is equal to 3. Y is equal to 3, x is equal to 3. There's your solutions. Check it. Let's check it in this second equation to see if it works. 5 times x, that's 15, minus 6 times y is minus 18. 15 minus 18 is equal to negative 3. That's what we wanted. Correct answer. Okay, so I hope that makes sense. See how you go. You can always multiply equations by certain numbers to try and make the numbers match. Have fun.